Welcome back. Today I'm going to be going over 2.5 in our geometry course, which is addition and subtraction properties, right? And in my opinion, this will be like the first major set of properties that are important for proofs. So yeah, just look, anticipate memorizing some theorems, right? And if you haven't watched my previous lesson, I recommend you do so, but I don't want to waste any more of your time, so let's get right into it. So first things first, we have the segment addition postulate, right? Which is really simple actually. It has to do with adding distances together, which I kind of talked about way back. Um, Essentially, if you have 3 points that are collinear, like right in this case, right, A, B, C are collinear, then um, you have AB, right, segment AB and segment BC. If you add those two, right, you get segment AC. Pretty simple, right? So once again, they have to be all collinear. Now, the natural continuation of that is the addition property, right? And what I've highlighted here in purple is the theorem you should definitely know, right? So again, if a segment is added to two congruent segments, the sums are congruent. Make sure you know that theorem. Now, what does that mean? Well, I have a visual here, right? So you're given this, right? Um, this specific diagram, and they tell you that AB is congruent to CD. Okay, so once again, right? AB is congruent to CD. Then they tell you to make the conclusion that AC is congruent to BD, right? Once again, I've highlighted those in green. Now, the reason you can actually make that conclusion here is because if you notice, right, you're starting with congruent segments, right, A, B, and C, D, and you're adding the same segment to both, right? So once again, going back to the theorem, right, if a segment, right, which is BC here, right, you're adding that segment to two congruent segments, right? You're adding that to AB and CD. So therefore, the sums AC and BD are congruent. That's for segments, right? Let's move on to angle addition, right? Similar logic, right? If you have angle BAD here, right? That's BAD here is the sum of the red and green angles, right? BAC and CAD. So once again, I feel like that's pretty self-explanatory, right? Because of course, these two angles that are adjacent to each other, they're gonna add up to one big angle, right? So once again, that's how angle addition works. Now, oh yeah, just as a side note, I think you might have seen this a couple of times um, in my previous lessons, but just know identical marks signify congruent figures, right? And I'll explain that more, maybe if you get to a proof later. But yeah, if anytime you have markings that are similar or the exact same, that means they're congruent things or congruent figures involved. Okay, now, right, same thing, addition property, right? For angles though, this time, not segments. If an angle is added to two congruent angles, then the sums are congruent, right? How does that look? Well, let's say we're given the white angles, which are congruent to each other, right? That's what we're given, and we're trying to prove that the green angles are congruent. Well, once again, you can actually justify that, right? Because what you're doing is you have two congruent angles, and you're adding an angle to both of them, right? So once again, if you add this blue angle to um, EFJ, right? You get the green thing, right? This entire thing. And if you add the blue angle to HFJ, right? Well, again, you get the entire thing here, right? So once again, you're adding the same angle to two congruent angles. And moving on from that, right, there's another variation of the addition property where if congruent segments are added to congruent segments, the sums are congruent, right? And of course, that's true for angles. Now, This one might be initially confusing, but I'll try to explain it both visually and mathematically. So let's say you're given AB is congruent to XY, right? And feel free to pause the video if you just want to like look at the problem first, right? But once again, avocado goes in orange. You're given that the orange segments are congruent, that the green segments are congruent, and you're trying to prove that the red segments are congruent. Well, once again, using this theorem, right? If congruent segments are added to congruent segments, as sums are congruent, you can actually justify that. Because since you're adding two pairs of congruent segments to each other, the sums are going to be obviously congruent, right? How I like to think of it, right? Let's say AB length was A, right? That means that XY also has to be A, BC, right? Let's just call it B, and therefore YZ also has to be B, right? If you add those two, well, you get A plus B as entire length, and you get A plus B as entire length, which are equal, right? So that's the more mathematical way of thinking about it. Similar logic for angles, right? Once again, if you're given that the green angles and the red angles are congruent to each other, right, you can make the conclusion that the purple ones are going to be equal, right? Because we're adding congruent angles to each other, right? Pairs of congruent angles. So 1 and 3 are equal, right? 2 and 4 are equal. You add those two together, you get the same overall sums, right? This is going to be equal to this. Okay, moving on from that, we have the subtraction property, which is just reversed, right? So now this time, if a segment, and again, this is a theorem, if a segment or angle is subtracted from congruent segments or angles, then the differences are congruent, right? Once again, it's literally just backwards. If you have that AC and it's congruent to BD, right? You can make the conclusion that these orange segments are congruent because you're subtracting BC, right? Which is common to both. So because it's common to both, we can subtract that and the differences are going to be equal. Similar kind of logic, right? If with the congruency, right, pairs, if congruent segments are subtracted from congruent angles, the differences are congruent. So if you're given that the purple angles are congruent to each other, and you're given that the green angles are congruent to each other, well, you can subtract the purple and green, right, to get the red, and do the same for this angle here. And of course, right, that red angle is going to be the same, right? If you want the more mathematical way of thinking about it, once again, let's call the purple C, let's call the green A, right? So if you want to find red, well, you just subtract A from the overall angle, right? So you get C minus A for the red angle here, and similar thing, right? Do C minus A, and of course these are equal. So the differences are congruent. Okay, all right. So now a helpful tip, just to kind of expect where you would find these improved questions, right? Like how do you know when to use these theorems? Um, an addition property is used when the segments or angles, right, in the conclusion are greater than those in the given information. So anytime you're trying to prove something that has like a greater measure or a greater length compared to what's given, you use addition property, right? Because you're adding two things together, right? You're increasing a specific measure or length. Subtraction property, of course, is used when it's smaller, right? When the things in the conclusion are smaller than the things in the given. Because you're trying to go from bigger values to smaller values, you use subtraction, right? Because you're trying to decrease the measure or length. So we're going to go over this proof question. Right? Once again, try your best to like approach this yourself first. Okay, so first let's look at what we're given. We're given that J and K are trisection points of HM. Remember, right? Trisection points means that those points divide HM into three congruent segments. We're also given this GH is congruent to MO. So I've highlighted the GH and MO in purple, right? And I've indicated the trisection part in the diagram, right? Because once again, right, those red markings indicate that these three segments here are congruent, right? Once again, right, J and K trisect HM. That's why these three are congruent, dividing into three equal sections. So now you have to conclude that GJ is congruent to KL. How do you do that? Well, what's the first step, right? Remember, write down the givens. So I wrote down the trisection points, right? Then what's the logical conclusion we can make from the given information, right? Well, if J and K are trisection points, well, of course, you're going to have these three segments um, that are going to be equal to each other, right? Because that's the definition of a trisector. And of course, I've used that theorem, right? If 2 points trisect a segment, they divide the segment into three congruent segments. So, right, what that actually allows us to do, think about what our final goal is, right? GJ and KO. We're trying to prove that white or these gray segments are equal. What you'll notice is to get from GH to the GJ, right? You have to um, add HJ, right? Similar logic. To get from OM to OK, you have to add KM. But in order to do that, we have to probably prove something is congruent, right? And in this case, we're trying to prove that HJ is congruent to KM, right? Well, thing is, you can actually prove that already, right? You can prove that HJ is congruent to KM because if you think about it, these are trisected, right? So of course they're going to be congruent to each other, right? So once again, we can make that conclusion. In the proofs here, I did write the subtraction property, but I'd actually say this is wrong. Um, I wouldn't even, I would say step 3, and what I would say is refer to step 2, right? Because we've already proven that HJ and KM are congruent to each other because they're trisected. So yeah, once again, I would actually cross out the reasoning here for 3. But once again, let's write down what else we have. We know that GH is congruent to MO, right? So of course we're going to write that down. So now we have proven so far that the purple segments are congruent to each other and the green segments are congruent to each other. Okay? Now, our conclusion was to prove that these segments here are congruent, right, in gray. So, well, think about what we have. We have a pair of congruent segments, right? And then we have another pair of congruent segments. So we can, well, use the addition property, right? Because you can just add these two pairs together and you're going to get these overall sums, right? So think about what property you use though. You have congruent segments, which are being added to congruent segments. So likewise, you're going to use if congruent segments are added to congruent segments, these sums are congruent, right? So make sure you're actually you're using the right variation of the addition property. And it's helpful just to kind of look at the diagram, right, for you to determine which version of the addition property is applicable to the problem. So yeah, that's our final step. And of course, we can write our conclusion now. So hopefully that made sense, right? Once again, in my opinion, these are the most important, like the first major important set of properties you should know, right? Addition and subtraction. Will show up in proofs a lot. So, but yeah, I hope you enjoyed the video. If you have any questions, leave it down in the comments, and I'll see you next time.